Hey guys, how's it going? I hope you're having a good day. Today, I really wanted to take this time to go over what I would consider much more of a production machine learning pipeline. I know that out in the wild, right, you'll see a lot of Jupyter notebooks and all that fun stuff, but this is really more focused on what do you do once your model is good or you have a data science team? How do you actually do ML ops? Locally, how do you move into the cloud? How do you automate it? That's really a big piece, right? Like you'll see a lot of AWS tutorials pointing and clicking, and then eventually you realize, holy cow, I have things that have been stood up forever and I'm getting charged a lot of money. So this is really what I wanted to explore today, was creating a project for you all that lays that out. So let's go to what will eventually be our end goal. This is, again, high level README. What we're going to end up using is this is a code only deployment of this production pipeline. What do I mean by that? I'm trying to stay away from using the AWS GUI. We will see it just so that I can show you how the buckets were created. There's actually files there. But what we're going to do is we're going to use Terraform to stand up almost all of it. If you're not familiar with Terraform, feel free to check out the documentation. It's great. Ask ChatGPT, ask a million resources on how to get started with Terraform. But Terraform essentially is going to create all of our online provisioning, our VPC, our ECR, our ECS, where our buckets get stood up, how everything gets pointed to, CloudWatch logs, the whole 9 yards. We'll also use GitHub Actions for the auto deployment of those images. So what's going to happen is we're going to, when we push something to the main branch, for example, those images will automatically get generated, sent to the ECR repository, and then, obviously Airflow will be able to pick it up. Docker and ECS, for now, on the quick start you're going to see in a second, we're just going to be using Fargate because Fargate is used behind SageMaker behind the scenes, but it is set up and provisioned to be EC2 ready. And then SageMaker for training and hosting, we're going to be using an XGBoost model. I know XGBoost is super popular. I've used it a bazillion times in my career at this point. And then eventually we're going to get to what we have here, an actual Airflow deployment, how it's getting provisioned, how we set up, the environment variables, the whole 9 yards, so that we're actually deploying a legitimate machine learning production endpoint. Here's just, again, some of the couple of things that you'll be able to see, right? This is using Airflow 3, which is fantastic. The GUI's gotten a lot prettier since Airflow 1 or 2 that I've used. So this was a lot of fun to deal with it. And then eventually we'll get into like how the GitHub Actions get set up, and you can see some of the builds have succeeded such that, they're pushing to ECR down here. And it uses AWS and it uses OpenID Connect. And then how do we actually smoke test it, right? Like Kevin proved to me that you've actually have a machine learning endpoint and it give me a prediction and it could be run in production. That's what this last guy is doing from our terminal. So without further ado, let's get started into how to actually do that. One thing you'll notice is that I have this quick start, and you're going to notice there's very few steps. That was the idea. I really fell in love with the make file while creating this repo. Why did I fall in love with Makefile? Because it's very easy to generate steps, and at the same time, you can obfuscate a lot of the terminal commands, and it makes for easy presentation. And also makes it a lot easier for yourself to just have to click up and down a couple commands as you get into production. So let's go into VS Code and actually follow this quick start. And you'll notice there's 1, 2, 3, 4, 5, 6 steps. And by the end of it, we actually have the endpoint. So let's go through it. We're inside of VS Code. You'll notice that the quick start looks exactly the same, which we love. What I did from here was I also deleted everything. So if I mess up anything, we're going to do it in real time because I hate when videos are curated and, there's environment variables sitting in different spots that people don't really know about. And, once they try to follow along, they're not able to reproduce it. So I did everything, even from the ground up, all the way to the requirements and the virtual environment creation. So first off, let's start back in the root directory. Again, you're able to pull down the GitHub repo onto your own laptop. And so I have the ML prod pipeline. You'll notice that I do not have any current environment up here, which is what we want. And I'm just going to follow these directions straight up, right? Just like I would expect you to. This make setup will allow you to create that virtual environment. So if you ever come over into the make file, I know it just seems like a ton of bash commands, scripts, the whole 9 yards, and it is, but it was designed to help automate a lot of the process so that you could follow along. So you could always come in here and go to setup, and you can see what the directions are actually doing, right? So you can see that it's creating this virtual environment, it's upgrading pip, and it's installing the requirements.txt. I don't want to stay here in the make file forever because there's so many different commands, but a lot of what the README is doing is just referencing this make file, which is great. So you can see that I have now set up the environment, and now I have this virtual environment sitting up here, which is nice. Everything important is installed. I'm happy. Let's go to the next one. The next piece is you're going to need a .env file. So I am not going to show it, right, because I don't want to show credentials, even though all the credentials will be long deactivated before this video is published. But anyways, outside of that, what you're going to do is you need to create a .env file. I know someone will say, oh, you could have used AWS configure, made your life easier. Definitely. I just wanted to get it out there for everyone, so that way they were most comfortable just putting it in a .env file, having the make file reference that, having Airflow reference that, just kind of having one unified spot. So come in here, fill out your access key, fill out your secret key, fill out your profile, fill out region, your prefix, and then your GitHub token. You will need a GitHub token. So go into GitHub, just make sure that you click developer settings, create GitHub token, all the fun stuff. Once you have all those generated, you can come in here and do the make env check. And you'll see that I have all my settings set up, right? This is really your first smoke test to say, hey, did I get everything that I needed to have done? And the answer is yes. Now I'm going to go and I'm going to create and set up Terraform. So Terraform, again, is just going to talk to AWS automatically, makes my life easy. And so I created this make bootstrap command. It's really just, if you're familiar with Terraform, it's really the init command with a couple extra pieces, right? So I can just do make bootstrap, and we'll just be able to see that it's initializing Terraform. Fantastic. Make plan is, again, same as Terraform, using Terraform plan. It just auto approves, a couple things like that. It's just going to show me the plan that is Terraform plans to take inside of my AWS account, so it can set everything up. So we'll take that for a second. And you can see everything, all the VPCs, all the artifacts that are going to get set up, all the fun stuff. And then what we're going to do is we're just going to apply those changes, right? So plan, for those of you not as familiar, plan just stages it. Does this look good to me? Yes, it does. It's going to add 43 things, different AWS resources, pass, buckets, the whole 9 yards. I'll do make apply. Keep in mind during this time, it's going to take some time to provision all these resources, right? It's creating 43 different ones, so it takes a couple minutes. So just hang in there and I'll restart the video when it's all done. So cool. All the resources got stood up, and you can see that these are the outputs of Terraform. We have our artifacts bucket, our data bucket. Again, I don't want to bore you with too much details. These are just the litany of things that are required to stand up for this prod pipeline. The security groups and just the various ARNs, the log buckets, the private subnets, VPCs, the whole 9 yards. So now what we're going to end up doing is we're going to run this make, build, and push. Now, it actually makes sense to come inside of the make file and look that up. You can see inside the make file, we have this build command. All it does is it just builds these images and pushes it to our ECR repository. And again, I'll show that in a minute. And you can see it's just calling the services, the training, the inference, the services, which is the batch, right? So if you came over here into the side, it's all these services. And each one of these services has an associated Python file, a features, an inference, and then training. They each have a Python file associated with the Docker file, which will then be created, which gets put to ECR, which eventually our endpoints will end up calling. So without getting too deep in the woods, right, this isn't a what I would consider fully stacked out XGBoost model, but the high level is that's what it's going to do. And we're just going to have like a training setup. So you can see here's like the main file, and then we're going to use an XGBoost.train. We're going to set up the data and put some temp data inside of S3 to even make that run. We'll get back some AUC scores, which I'm sure they won't be good because again, this is just made up generated data. The idea is that we're running an Iron Condor. This is trading for those of you who care. fantastic. For those of you who don't, it doesn't matter, right? That's the beauty of this infrastructure. It doesn't matter what you're doing it for, just that it works. So I'm just running in a data frame, and I want to know, will an iron condor be successful this day? That's in options trading, right? So for those of you familiar with like SPX options, I want to know, will this condor make me money or not at the end of the day? And so eventually I want to save this model, and at the end I want to make predictions, right? Will this help me, make better credit spreads, and will I make more in financial markets or not? So all those get built with obviously the build command, and then the push command does an automatic ECR login. Again, you can go up the makefile and check out the ECR logins and reference it. It does a lot of different things, but essentially it ends up pushing the training, the inference, and the batch images under this single command. So let's do that. You see it's underway. All the Docker files over here are being called. It's writing them. It's eventually going to push these guys out inside of Amazon Web Services, and we will go check those out once they're fully pushed. Okay, fantastic. They're up. Let's go look inside of them. Oh, cool part, right? They're all here, right? We have the batch, the features, the inference, and the training. Let's just click on the training, for instance. You can see the image tag is the latest one. You can come inside of here, right? Check anything out that you'd like, but it's here. It's fantastic. That's what we're going to need to use the training of the XGBoost model. You'll notice step number 5 is let's make some data, right? At some point, we just have to have some data in order to do some training. So I have a simple command, just prep some data for this project, and it's going to automatically push it to the S3 bucket that Terraform provisioned for us. Cool, it says it's up. Let's go check it out. Awesome. It made it into the bucket. Again, this bucket was auto-provisioned by Terraform up here, and then it just created this features subdirectory, and then here's our training data, which is fantastic. Now, let's actually train this data, right? Hopefully we've provisioned everything correctly, right? We have our images up there. We'll train this SageMaker model. Let's hope so, right? So we're gonna make SM train, and just like I have in the README, it should show a pretty similar output. And so, yep, it's starting to train the model. It takes a couple minutes, right? It's, again, not that much data. I think I put 10 to 11,000 rows, and it's just gonna, do a couple training sessions. It's gonna do a little hyperparameter tuning, right? Just all the traditional stuff you would get in a machine learning workflow, and we'll wait for it to finish. So it's all finished, which is fantastic. Obviously, training complete. Let's go inside of SageMaker just to see what it looks like there. You can see that the XGBoost has finished. Now you might be like, hey, wait, this time looks a little bit different. It is. What happened? This max time exceeded, and these 2 stopped runs happened because the instance type was actually not available in the region at the time that I ran those, so I had to kill those jobs and create a new instance type, which is always available. In my make file, I basically had to change an M5 to a T3 EC2 instance. Not a big deal. I'll show you really quick what I mean. You can see that here, this is an ML T3. It used to be an M5. I have always had an M5 here for actually every run except for these last couple, but it just wasn't available. Just a quick gotcha that sometimes that happens in cloud computing. That's where you build in redundancy or backup plans. That's why Airflow has retries, which is why we make these production pipelines in the first place. But in general, this T3 or the M5 is almost always available. So you can just switch this briefly in the makefile if you'd like to. Now we're on step 7, which is create the endpoint. The endpoint takes some time, actually about 10 minutes to create. So I've actually already fired this off. It will take a couple minutes, but let me show you what it looks like when you first fire it off. It's using the latest training job that we have, right? The 2025 with the time-stamped version. And then it's using this artifact. Here's the model ARN. Here's the endpoint config. Here's the endpoint ARN. And then in the makefile, I always put in a little bit of commentary, right? It's waiting for the endpoint to serve. It's going to take about 10 minutes. We'll be back once it's up and running. Little tidbit while that gets up and running. You can always come inside of these log groups inside of CloudWatch, right? Again, they've been provisioned for you, especially with all the Terraform resources. So you have your log groups, you have your SageMaker, your training jobs, and these will all honestly always naturally have a group anyways. And then you can come inside of the Condor XGB that we just ran, and you can actually see the logs, like what's printing out, right? So if you're ever like, hey, I set up this job, I actually don't know how to debug, like, am I getting results? Did something finish? Here you can see, here's our data science aspect of our pipeline, right? We have a lot of validation AUCs that are coming through. It's doing hyperparameter tuning, and it's basically printing out over the course of some time the best validation AUC and eventually our ultimate AUC. Now, again, for the data scientists in the room, which is exactly how I started my career, I still consider myself a data scientist, right? We wouldn't be happy with these results. Maybe it's, I mean, again, it's better than a 50-50 shot. Is our data balanced? Is it imbalanced, right? Would really give you an indication. If it was super imbalanced, we would use AUCPR. I digress again, but anyways, we can see that we have an AUC, the model has finished, so we're confident the model is done legitimately training. And so what we're serving to the endpoint is actually going to be some functional machine learning model. And just, again, we're trying to be code only, but just to let you know, we're inside the models of the SageMaker AI platform. We can see that the latest model is here. So everything is working up to snuff, again, the way we would anticipate. And then we can also go into the endpoint configurations. And you can see that this endpoint is being created right now. So this is going to be our Condor XGB endpoint. It's still provisioning. Again, we've done this completely from our code base, but it's here inside of AWS. If you ever really do want to check it out, debug it, quickly go to CloudWatch, sit in the GUI in general. Here it is. Okay, if you look at that right here at the bottom, right, the endpoint is ready. So it's up, it's running. It did take, 5 to 10 minutes to get up and provision. Very small model, not a big issue. So now what we want to do is want to go to the next step, right? We want to send a smoke test to the API. Smoke test high level is just example data, make sure the endpoint's working, give us a prediction back that we would use in production. So I'm going to run make sm smoke test. It's invoking the endpoint and bango bongo, right? Here we have a probability, we have a response. In this case, right, for this Iron Condor pipeline, which is what, the training data was on, that we could say, again, this is a mock piece of data science for the production ML ops. We could say this is a very low probability. Let's say this is not a good day to trade an Iron Condor, for example, whatever that means. And the features that we built for the day at the end of the funnel, don't trade this Iron Condor. We don't think it's going to be profitable. So let us know, stay out of the markets that day. Obviously, if the probability came back very high, maybe it would be in the markets that day. This is a good binary indicator. And again, a lot of data science would go into actually producing us a legitimate probability. It's kind of funny that data science boils down to really just this single number in most production pipelines, especially binary classifiers or gradient boosted trees in general. But that's what we have. We have an endpoint. We're happy. Now, some of you are questioning, hey, where is the airflow? I didn't see you do the airflow. I know. And I don't mean to be the guy that says, come to my next video. It's just the way it worked out because this was the easiest way for me to explain what was happening chronologically before actually getting to the airflow. So that way, when we get to the airflow, it runs through exactly the way we would expect. So when you come down here, one thing you can do always in between that I want you to keep in mind is you can tear everything down. That's honestly my favorite part about Terraform, is not that it stands everything up, which again is phenomenal, but it tears everything down because it's a great declarative language. What do I mean by that? I could run a simple, right? Like, let me clear this out. I could run a make down. This is a command that I made in the make file, but it's essentially Terraform destroy. And what it does, my make down is equivalent to what I created was a couple make file commands. SageMaker teardown, empty the buckets, nuke the ECR, and then destroy all the Terraform resources. So you might be wondering like, hey man, this is taking me a couple days to stand up just like it took me to make the video. I don't want to have all these NAT gateways and everything charging me this whole time. How do I spin it up, tear it down, spin it up, tear it down during dev? That's my favorite part. So one thing that I, again, made in the make file, because I'm make file heavy, was I made a little cost function. So that way I could see about how much I'm being charged. So right now I'm on the 6th of the month and I got $4.50. Obviously, if I let this run, especially MWAA, which is the managed airflow, you can get really high bills, especially as like an individual. If you're a company, obviously it probably doesn't matter, but you could get $500 to $1,000 bills if you're really pumping hard. And big companies, Coinbase, the likes that I've worked at in my past careers, right, their bills are obviously extremely high, but they have the revenue for it. So as an individual learning this or spinning this up on your own account, right, you're trying to make this like under $10 or whatever the case is. This is how it will help you. You can learn, you can tear it down, you can be confident and all that kind of stuff. So in the next video, we are actually going to talk about airflow, right? What will happen? There's a couple extra configuration steps, but it's really not a big deal. We're going to nano, just a high level. We're going to create airflow, and then you're going to see the original commands that we had last time. We're going to build and push. We'll actually talk about using the OIDC connection to GitHub Actions to do it automatically. We'll run a couple Airflow commands, we'll run a DAG, and basically the reason I made the video in this ordering is because it's going to run just the same chronologic steps. Basically the makefile instructions, right? The makefile commands we ran here are basically just going to run in Airflow automatically. So you're going to get a feel for how the DAG is processing is what you just did manually when you set it up. So guys, stay tuned. I'm really excited for the next video. Hope you learned a lot. Thanks.